this video, Columbia University's doctoral candidate, Rashidul Berry, will teach Newton's.
We're going to talk about friction. A long time ago, a man named Aristotle started thinking about it, tried to understand why objects in motion slow down, and he hypothesized that objects in motion slow down because they get tired. So of course, now we know that he was wrong, because now we know that, oh my God, Sir is missing. So of course, Sir Isaac Newton told us that why objects slow down. Objects slow down, according to Sir Isaac Newton, because of friction. And how they slow down actually is something to do with this graph. This is called friction graph, and today I'm going to help you understand this friction graph. This is force of friction at the y-axis. This is applied force at the x-axis. This is static friction, and this is kinetic friction. Static, and this one of course is the kinetic. All right. Let me show you the simulation. So let me explain what is going on. The box is 10 kilogram box sitting on a road. Mr. Berry is trying to move this box by using a rope with his car. Now at 0 second, Mr. Berry applies 0 Newton. So what happened? Nothing happened. The friction is 0 because object is at rest. Well, this is a big misconception. Friction is 0 not because object is at rest. Friction is 0 because Mr. Berry applied 0 Newton. Few moments later, at 1 second, Mr. Berry applied 10 Newton. What happened? The friction is now 10 Newton. Friction increases to keep the box at rest. So friction can increase. What type of friction are we talking about? We are talking about static friction. Yes, according to Sir Isaac Newton, there are two types of friction: static friction when object is at rest, and kinetic friction when object in motion. And the coefficient of friction for static friction is mu s, and coefficient of friction for kinetic friction is mu k, and mu s is always greater than mu k. So let me go back to this story. All right, at 0 second, Mr. Berry applies 0 Newton, so force of friction is 0 Newton. At 1 second, Mr. Berry applied 10 Newton. Now force of friction is of course 10 Newton. Box is at rest. Because why the box is at rest? Well, in order to move the box, Mr. Berry has to apply more than maximum static friction. What is the maximum static friction? Maximum static friction is right here on the top. Maximum static friction is right here. What is that maximum static friction? Maximum static friction for this problem is 39.2. How it is 39.2? Is 0.4, which is mu s, times Fn, which is 98 Newton. Now, increase the force. So he applied 38 Newton. Now what is the friction? Friction is now 38 Newton. Is the box moving? No, it's not moving because 38 Newton is not enough. What is enough? 39.2. So now Mr. Berry applied 40 Newton. Okay, he realized that 38 is not enough, so he need to move the box. So he applied 40 Newton. Now what happened? When he applied 40 Newton, as you see that 40 Newton is more than the maximum static friction, which is 39.2. Now the box will start moving.